Okay, here we go. Um, Took a while to get started because the phone wanted to give me 47 messages. I got no phone plan. There's no what they call load. It only works in the U.S., but it sent me 47 messages with no phone number. I don't know how to do that. Okay, we're going to talk about electrical distribution or lack thereof for Villa Cecelia. That's my salvo up on the fan deck up there. It starts with this pole that's right in front of us. This picture's about 3 months old, and I've just noticed that my meter base and my 175 amp breaker and my pipe up to the weatherhead no longer, yeah, are no longer in the building. These bolt holes here attach the straps for the pipe. There's 3 sets of them. Anyway, I'm not sure where the meter is, but it's not on that pole. 20 feet to the left of this picture is the Meralco transformer on a concrete pole also. But I can't get past the city electrical engineer. He charged me 4,000 pesos the first go around and 5,000 the second go around. He still hasn't given me the piece of paper to hand to Meralco. Anyway, what we're talking about here is electrical distribution. Just to the, where's my pointer? Just to the right of the pole here, in that round window, you can't see straight through the house here like all the other ones because there's a wall there. And across that room, it sort of cuts it, a third of the room off. And on the other side of that wall is our electrical distribution center, main breaker room. So there's the pipe buried under the ground here about 4 years ago. It's well disguised now. And you can see the shape of the house. It's 10-sided. It's like an octagon or hexagon, except it's got 10 sides. So we have to get electric spread all around that house. I start out with the main breakers as close as I could be to my pole here, and not be like on an outside wall. So now let's take a look to see what we did. We're going to change format here a little bit. Okay. These are 2 breaker boxes that are on that wall. Behind the window that you can't see through because it's a wall in the middle of the room. We have 1, 2, 3, 4, 5 times 2, 10 sub panels. They're all on the fan deck, fit flush into the 10 posts, or right on the main load path of the house. We have 10 posts, and coming in, we've got 2 conductors of number 2. That's not 2-aught, that's number 2. It's 95 amp capacity. 2 on the left leg, 2 on the right leg, and white doesn't show up on the screen, so I colored this blue just for this demonstration. This is the white wire. The transformer has a white wire on it, but they won't hook it up. Or they say they won't. I don't know. Electrician tells me all you have to do is ask them, but they won't do it for the expat. These boxes have 2 grounding bars in them. The one for the white wire here, if you were going to use 110 like a split system. And the other side is the green bond wires. This piece on the bottom is removable. Depending on what country you're in, how they want it wired, you can take the bar off and lay it in the bottom. There's a large breaker at the top. It's 200 amp. Even though the one at the meter base is now a 175, they downsized that. But my wire would be good for 200 amp within a temperature rise. And in these cabinets, there's 60 amp breakers. Now, they're pretty much all 60 amp breakers at this point. 2 cabinets full of them. Because if you had 1, 2, 3, 4, 5, that much right there would just feed those 10 sub panels. And now if we want an electric stove or a induction cooktop, a clothes dryer, hot water heater, all that big amp stuff, then you'd run a direct route from your panel box to that. Because of the way we set up an electrical room, and because they have required me to have 177 breakers in this house. I've never heard of that before. I have a 27 breaker panel in my machine shop, and half of it's not in use. And I run machine tools and lights and receptacles and whatever. Anyway, the way we set this up, we put about 3 feet between them. And just to make it easy to work with, and because we had it, wanted to show butt, I guess, we ran the sub panels for half the house clockwise around the house off of this one. And this one is counterclockwise around the house. So there's a lot of empty breakers in here. But if we hook up a welding machine or I don't know what kind of tools, I got every kind of tool we can name, but they're not here. I'm probably going to put in some kind of a table saw with a line bar on it. Okay, so leaving this, we got number 4 wires. There'd be one black and one red. And in this pipe with the black and the red, there's a number 6 white wire, in case we ever wanted some, a little bit of 110 someplace. And we have a number 12 green wire. That's the bond wire for the receptacles. That's the third round pin down there on the bottom of your receptacle. So this comes in, standard Filipino electrical box. There's no main. You run it through the breaker backwards, and that works. I did that with control transformers when I used to do industrial wiring. Works just fine. And I assume that the breakers are the same here. They're all General Electric. What I used before was General Electric. These are General Electric. I have used some Cutler Hammer on big breakers too. But these are all General Electric. So, some of the boxes, just because we had them, we put 210 breakers up here. These are receptacles. That's 60 amp receptacles. And that's for one of the 10 wedges of the house. So 60 times 10, we have 600 amps we can hook up on a 200 amp meter base. So we're not bound up on connecting anything up, not until it tries to go through the meter. Okay. Oh, these two are lights. We got 196 light bulbs, LED light bulbs in this house. They come off those 2 breakers. Total amps is about 4, for 196 bulbs. If you divide volts by the watts, you come up with amps, and it's like 0.013 or something like that, times 196. Okay. We don't use wire nuts except for the terminal end on light fixtures. They're supplied with no other way to hook them up and bare wires hanging out of the light fixture. Then we use wire nuts. They call them B-caps, ideal wire nuts, B-cap, whatever you want to call it. But everything else is to a screw. So those 3 breakers, 3 pairs of wires come down, and this is a polypropylene terminal. It's 1.5 inches wide, about 6 inches long, has 6 individual ports. They're not connected together. They're individual pass-throughs. And the metal's good and thick, and it's got a stout screw on it. So you can put, I don't know, you could probably put 6 wires in there if you wanted to. I'll get to in a minute why I did that. Okay, so if we have a pipe coming from a receptacle location in the wedge that's underneath of this box, all the pipes down there have 7 wires. That's 3 independent receptacles and a bond wire. Some of them have got 9 wires. And the deal on that is for switches. Like I drew one here with here's the light. A light would have 3 wires because it's all the conduits are home run to a cabinet. Nothing put together out in the middle of any place. We just keep gluing pipe together until we get back here. You put a plastic bag on a piece of fishing line, suck that through with a shop vac, then just pull the wires with the fishing line. Works really easy. We did 3.5 miles of wire in 2 days. Took longer to untangle knots in it than it did to run it. Anyway, you have to get 2 wires for down here. So what we do is we pick one of the wires, that's the yellow wire, directly off the breaker, or off the thing that comes from the breaker. And the other one, just like on a 7 or 8 wire box, the receptacles have a wire on this side and this is not drawn correctly. This blue wire should be on, this light blue wire should be on this side. I guess I'll fix that later. Anyway, we're tapping off one side of the 220 through a light switch, which is in this receptacle box. In other words, we would put 2 receptacles and the light switch. The light switches have the same cutout. We made our own face plates. I couldn't buy anything here that suited me. So I made them out of 1.2 millimeter or something like that. I want to get them galvanized, barred out. I'm just going to make another set while I'm here out of stainless. I brought all the carbide saws and stuff that I saw them out with. So we pick up one side of the 220, go through the receptacle, come up, and it goes over into the light. The other side of the 220 is off the same breaker that this was fed from. So that gives us the other half. Every pipe has got a green wire. I don't care if it's a light, a receptacle, or just a pipe with wires in it that nobody knows what it's for. Got a green wire. They all have to be connected together. So what we have here is called grounding bars. If you download your National Electrical Code, it's in like 27 sections. You only need 2 sections. Residential housing, and then just the one on distribution, which it's more for businesses with real electric draw. If you only have to download one, get the residential housing one. It will tell you you're required to have a bond wire to get a certificate of occupancy to live in your house. When they passed that law and passed the code, they did away with this grounding bar that used to sit right in here in the enclosure. There's a cover goes on this too, which is just not in the drawing. So this is a solid chunk of brass. It's got a big screws going down through the top. They thread right through to the other side. And you put your wires under those, and when you tighten them down, it connects all of them together because there's no insulation, no plastics. Any place you put a wire that touches that bar, it's the same wire. It reads the same with a voltmeter. Over here, we have a little smaller one. This is for the white wires. If we do 110, then we'll run the white wires, which are in the pipe already. But we're going to hook them up as standard receptacles. But if we go to 110, then we'll take the one wire off of that and stick it on here. There's a number 6 wire going back to the big electrical room into every one of these sub panels. So there's actually 2 extra wires in this rather than the one I'm using. I could put a ceiling fan, which could be through this same pipe. You might want to be able to switch the light on the ceiling fan on and off, and then the fan separately. And this This receptacle here, that position, that's where a door goes from one wedge into the other. Like if you were in bedroom 4 and wanted to walk into bedroom 3, the light switch that goes through the wall and out the other side is at that door, and it'll have the light switch for both rooms, and for the ceiling fan it'll have that. So we have ground bars to connect a bunch of wires together. We have a future ground bar for 110. When you're bolting it down, you may as well bolt everything in there. And this is a much larger terminal strip. It's the full width of this bar here. Now, you'll see pictures in the video, I think previous to this one. It's what made me do this video. That box was wired up. I don't like the way they did it. I mean, I really don't like the way they did it. This isn't to scale. It's not far off. But this space in here is only about 2/3 what it looks like compared to the size of the breaker. This is about 5/8 of an inch between the breaker and the wall. So you got these screws that you're going to put the wires in your breakers. If I didn't use that terminal strip, I end up with 4 wires under every screw. You can't see what you're doing around the corner down in that box. It's also dark down in there. I don't care what kind of light you got. If the light can see it, then you can't see it. It's in your way. So, the way they were wired up is you put a screwdriver here and lift that edge up and the breaker comes out. And while it's hanging out here, you stick all these wires in there and tighten them up. Then you snap the breaker back in. These are plug-in breakers rather than bolt-in breakers. I kind of like bolt-in breakers, but you can't get them every place. And I know I can buy both here, but trying to get any kind of quantity of them when you're trying to round up 176 breakers, 173 breakers, over a month and have them delivered, I went for this kind. I've used them for years and never been in trouble with the connection. I don't know if anybody else had trouble. I don't have trouble. Anyway, when you put this thing back, you have to bend all these wires and push them down in the box over here. And you have to start at the top and work your way down, because all these other wires got to go on top of them. You couldn't get them around wires from 1 or 2 below it and get them into the box. So you have to start up here, and this pushing wires down in there and moving them around, you check and turn this screw a little bit, make sure it's tight. If it turns at all, start over, because some of those wires are not under the screw anymore. So being that there was no room to do it, I don't like 4 or 5 wires stuck into a big wire nut and 1 wire run up to there. It makes a bird's nest in the front of your box that you can't do anything with. The actual box, when it's wired, will be just about as neat as you see here, except that this will be a sweet bend with the wires. They're so splayed out like that so I can separate the pairs for the purpose of this video. I knocked this drawing out in about an hour and a half just for the video. It's not for anything else. Anyway, that just repeats. 1, 2, 3, 5, and then another 5. Okay. Now, the part that does ugly the box up is coming next.